trigonometry, I guess, continued. So now that we've touched on the compound formulas, so those are the ones that you see here. Now, if you haven't watched that video, I made it just before this one. And so that one is, I'll put up a link up above there in case you want to see where these formulas are coming from. So the next one is the double angle formulas. Now, what are the double angle formulas? It is basically the utilization of these types of angles. So where you have, let's say, sine of 2 theta, right? So this is the double angle. Or you have cosine 2 theta. Or you have tan of 2 theta. So that is the double angle. Now, once we have this, and then we understand these compound formulas as well, or we have them at least, we can derive, double, triple, quadruple, whatever it may be. We can utilize these compound formulas for all of these. So I'm going to show you by utilizing, this, okay, how to come up with that, and then what it equals to, and then the same thing we'll do for all of these. All right, so let's give it a go. And so first I'm going to start with the sine 2 theta. Now, if you're doing sine 2 theta, well, just by looking at this, you can see that you can write it out as sine. Okay, well, 2 theta is basically theta plus theta, right? So that creates our double angle formula. And now what does this equal? Well, I mean, if I substitute it back in here and then utilize the compound formula, so what I'm going to get is I'm going to get sine, okay, of the angle number 1, which is theta, and then it's going to be cos of angle number 2, which is also theta, and then of course you're going to get on the other side cos of theta and sine of theta. So substituting all of that in when the angles, so if this is your theta 1, theta 2, but they're the same, then that makes things a lot easier for us to be able to do. Now, I can simply, so if I do this, let me factor out, let's say, sine theta, or you can factor out cosine theta. It doesn't matter, you'll get the same thing. But if I factor that out, I'm going to get sine theta, and then I'm going to get cos theta plus cos theta remaining. Well, cos theta plus cos theta is just 2 cos theta, because there's 2 of them. Now I can bring this 2 in front, and I'm going to get 2 sine theta cos theta. And that actually is your double angle formula for sine 2 theta. So if we wanted to, based on all of this, so I'm going to kind of remove all of this junk here. Let me just delete it. Then what I can say is that sine 2 theta is equal to, well, we'll just kind of derive this from the compound formulas. That's what it equals. It equals 2 sine theta cos theta. So that's my first double angle. Now, what if we do the same thing with cos? Well, we're going to get kind of the same trick happening here. So if we wanted cos 2 theta, well, that is equal to cos of theta plus theta. And again, I can just substitute it back in there. Now, if I substitute it in there, notice you'll get cos theta 1 times cos theta 2. But the angles are the same, so this is going to be cos, okay, squared theta, because it's the cos theta times cos theta, minus, and this is going to give us sine squared theta, okay, on the other side. So there is your second double angle formula right here. Now, because we have the square, right here and right here, we can have different kind of interpretations of the same cos 2 theta. So you can, for instance, we know that this cos theta squared is nothing else but 1 minus sine squared theta. And therefore, if you have that, and then here's the other one, then you can also write this as simply 1 minus, and notice now we have 2 of them, so this is going to be 2 sine squared theta. So this right here and this right here is equal to cos 2 theta. And again, so I can do the opposite. Instead of taking cos squared theta, I can take this right here, sine squared theta, and what I can do is, so I'm going to have cos squared theta minus, and then now we have 1 minus sine squared theta. 1 minus cos, okay, because of the sine squared. So this is 1 minus cos squared theta. And if you simplify this, well, as you can see, so this is going to be cos squared theta. You'll bring in the negative. So it's going to be cos 2 squared. And then we're going to get 2 cos squared theta minus 1 as our other, okay, kind of our last one. So let me clean this up just so that you can see what the 3 different variations can be for cos 2 theta. All right, so I cleaned it up. So we have basically 3 things, okay? So sine 2 theta is equal to 2 sine theta times cos theta. Cosine 2 theta is equal to cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. And it's kind of useful to be able to have those 3 variations because notice that in particular, so these 2, they only utilize one trig ratio, right? So the first one is just sine theta. So if you know that, you can find out cos 2 squared. And then the other one uses cos theta. So that is, useful. So it just depends what information you have available to you. Now, of course, trying to remember all of them is not always fun. Just like with the compound and then the equivalent ones, so those videos that I've done, these things just keep growing and growing on you. And then, your mind can only probably handle so much. So you have to be able to do these types of questions continuously. I'm just deriving it here, but we'll try to do also some examples and apply these as well. And you'll see that it's not very easy, right? You have to kind of keep things in mind. Now for the last one, so for this one right here that we have, so the 10, so that again is basically nothing else but, so if you want it to have 10 2 theta, this is just equal to 10, right? Theta plus theta. So that's what we would have right there. And if you substitute this back in here, okay, so if you substitute it, so the numerator, as you can see, is going to be 10 theta plus 10 theta. So that's just 2 10 theta divided by, and then now in the denominator, it's going to be 1 minus, and it's 10 theta multiplied by 10 theta. So that's just 10 squared theta. And then that is your last kind of double angle formula that you would have. And I think these 3 are, they're useful. You're going to run into them in advanced functions in the course that you have, I'm sure. Okay, so your teacher's going to torture you with these a little bit, okay, that you have within. Now, to end off this video, what I want to be able to do also is, one of the applications for from knowing the double angle is kind of trying to find out, sometimes you may be asked, okay, for instance, what is, okay, sine of theta over 2, right? So like, what if you wanted to know if there's a formula for this, okay? So if there's some kind of a formula. Or, you may also be asked, what is cos theta over 2, okay? So that's another one that you would have. Now, I'll do one of these, and then the other one you can do by exactly the same trick, all right? So for instance, let's say I wanted to find out the first one, which is sine theta over 2. And I'm going to find out the formula for this by utilizing, all right, so right here in green, I'm going to utilize the cos 2 theta. Now you might say, why are you using cos 2 theta when you're trying to find sine theta over 2? And that's the trick, right, in showing these. You also see the same thing in these trig identities, where you got to be kind of exposed and think about them. So it doesn't come naturally to me. When you're watching this, it might seem like, he can whip this up, and it seems very simple. No, I actually spend quite a lot of time on the background, and then even though I might be, teaching some of this, I still prepare and then go back and try to go back in my mind, okay, how do I exactly come up with these things? So don't feel bad. So I am going to use the cos 2 theta, and then just to show you that I can derive this sine theta over 2 from here. And what I'm going to do is I'm going to take, I'm going to use this, and actually this, because notice I see that sine theta there, or sine squared theta. So from here, I'm going to say, all right, let me take, okay, for instance, cos theta. Okay, now cos theta is equal to, it's equal to cos. Now, it's equal to 2, all right, and I'm going to put theta over 2, right? So the 2 and the 2 would cancel, which is really just cos theta. So now this is my angle, and now notice this is now my double angle formula, except my angle is pi over 2. And from what I just derived right here, I know that cos of the double angle is equal to 1, this is 1, minus sine squared of the angle. But my angle is now it is theta over 2. All right, so that's my angle. So I'm just using that formula just to substitute it in. And I want to be able to solve for this, right? I want to know what the formula for this is. So I can now manipulate this entirely. Okay, so what I have is, I have cos theta is equal to 1 minus sine squared. Okay, so theta over 2. So now solving for that sine theta over 2, I'm going to bring this term back to this side, this term back to that side. So I'm going to get sine squared theta over 2 is equal to 1 minus cos theta. And you can see probably where I'm going with this. The squared, I can take the square root of both sides, and I'll get sine theta over 2, and that's going to be 1 minus cos theta, plus minus. And that's a formula for sine theta over 2. Okay, so that's something that we can derive. And again, it's not an easy thing, right? You probably, now watching this, you'd be like, oh, okay, I can understand and follow, and that's definitely the first step. But for yourself, if you had to do it, it might take you a while, until your brain can finally kind of recognize, or somebody can point, hey, maybe you want to use that to try to solve it. So what I would encourage you to do to try to see, just so that you're testing yourself out, let's see if you can derive cos theta over 2 utilizing the same trick. Okay, so now cos theta over 2, so the trick, okay, would be, again, you can start with cos theta, which is cos 2 theta over 2. But now, of course, instead of utilizing this, which I used for sine, you can utilize the other, which is this one right here. Okay, and then solve for cos theta over 2 with regards to this. So I'm going to end it here, and hopefully, if you can get it, definitely you can put up a comment down below. I hope that you found this useful. It's purely just deriving these double angle formulas and then utilizing them in applications. That's where you learn, how am I going to be able to apply them. But I don't want to make this video too long, so this is just on the derivation, where the double angle formulas come from. All right, and I'll try to do maybe some examples in a future video. Thanks for watching, okay, and hopefully we'll see you in one of those future videos. Bye everybody, and happy studying in your grade 12 math.